control shift to camera on avutledhe. కెమెరా కనపడుతుందా?
లేదు సార్.
కానా మీరేదో ఆలోచన చేయాలా? టర్న్ కెమెరా అంటే రాలేదే.
ఏం లేదు సార్, మేమంతా మీకు ప్రెజెంటర్ చేసాం సార్. మిమ్మల్ని
ప్రెజెంటర్ చేశారు. నేను లాక్ ఆఫ్ చేసి మళ్ళీ వస్తాను. ఓకే, కెమెరా మాత్రం రాలేదు. ఒక్క నిమిషం.
ఓకే సార్.
ఏదైతే కెమెరా లేకుండా జరుపుతుంది దాన్ని, ఏం ప్రాబ్లం లేదు.
చెప్పేటప్పుడైనా ఉంటే బాగుంటుందేమో సార్, చూడండి.
నేను ఒక్క నిమిషం.
ఓకే సార్.
కెమెరా ఏదో సమ్ ప్రాబ్లం ఇప్పుడు దాకా జరిగింది. చూస్తాను మాస్టర్, మధ్యలో ఏదైనా చూస్తాను.
ఓకే సార్.
ఏదో సార్ ఇప్పుడు క్లిక్ అవ్వట్లేదు. ఏదో కెమెరా ఆన్ కానీ మళ్ళీ వస్తుంది. వేరే ఏదైనా వేరే పర్మిషన్ ఇవ్వ అవసరం లేదనుకుంటాను. ఒక నిమిషం. వీడియో కెమెరా ఆన్ అంటే మాస్టర్ పట్టించుకోవద్దు.
ఓకే సార్.
ఓకే, ప్రాబ్లం.
సార్ మాస్టర్ ని ప్రెజెంటర్ చేశారు?
చేశాం సార్. ప్రెజెంటర్ చేశాను సార్. ఇంత ముందు కూడా వచ్చింది సార్.
వచ్చింది ఇప్పుడు?
సార్ చిన్న మాస్టర్.
అదే
వచ్చింది సార్. ఇప్పుడు వచ్చింది సార్.
ప్రెజెంటర్ చేసిన తర్వాత వస్తుంది మాస్టర్.
సరే సార్, అట్లయితే చేసాం. ప్రెజెంటర్ చేసి
I will share the first topic.
ఓకే సార్, విజిబుల్.
సార్ ప్లీజ్ స్టార్ట్ ద ప్రోగ్రామ్ సార్.
ఓకే సార్. So good evening to all participants. On the occasion of 138th birth anniversary celebrations of Sri Srinivasa Ramanujan, our department is conducting a one-week online international workshop on mathematics, bridging ideas and innovations, MBII 2025, from 15th to 20th December 2025. Yesterday, Dr. K. Lavanya Madam, Assistant Professor, Department of Computer Science, Acharya Nagarjuna University, Guntur, Andhra Pradesh, delivered a talk on a mathematical key for understanding quantum computing in AI era. So, more than 500 participants attended yesterday's session. Thank you one and all for your valuable participation in yesterday's session. I request our beloved head of the department, Dr. Kevilan Acharya Garu, to address the gathering for today's session.
Good evening to all. On behalf of Department of Mathematics, I humbly welcome all of you to this international workshop. I extend a warm and heartfelt welcome to my respected teacher, Dr. L. Jagannathan sir, my esteemed colleagues and my dear students. It gives me immense pleasure to take this opportunity to say a few words as a convener of this international workshop and head of the Department of Mathematics, Bapatla Engineering College, Bapatla, on this memorable occasional week of the birth anniversary celebrations of Sri Srinivasa Ramanujan, who is applauded as a world greatest mathematician. As we gather here on this second day of our international workshop through online, I am honored to take it as a pleasure to address the gathering of such passionate participants. Our journey over the past one day has been a collective endeavor to enhance our computational skills and to expand our knowledge. I want to express my appreciation to each and every one of you for your sincere participation. It is through only your presence that we have transformed this event into a good platform for enriching knowledge. By this workshop, you will get an idea on innovative computational skills and various applicable methodologies. The wealth of experience in participating in any international workshop definitely may combine with increasing enthusiasm to learn new things and exemplifying to explore the spirit of continuous improvement. So I strongly believe that this program will be definitely a fruitful one with academic and active participation of our sincere students. Today we have a wonderful resource person with us. The resource person for today's section is Dr. L. Jagannathan Sir, Professor, School of Computer Science and Engineering, Vellore Institute of Technology, Chennai. He is one of my best teachers in my students' career. Dr. Jagannathan Sir is not only an inspiring teacher, but also a source of motivation, guidance, and unconditional support to the student community. I had a good association with him as his student and also as a colleague. He rendered his valuable services to Bapatla Engineering College from 1994 to 2004, 10 years. He inspired plenty number of students in his career with his best way of teaching and good qualities. On behalf of Department of Mathematics, I express my sincere thanks to Dr. L. Jagannathan Sir for graciously accepting our request to deliver his valuable lecture in our international workshop. Thank you, sir. Thank you very much.
Thank you.
All the best. Thank you, one and all.
Thank you, sir. Thank you very much,
Okay.
sir,
I'll
for your
start.
valuable message.
Okay. Fine.
Today is the second day in our 1 week online international workshop. Today's speaker is Dr. L. Jagannathan Garu, Professor, School of Computer Science and Engineering, Vellore Institute of Technology, Chennai. Now I request one of our staff organizers, Srimati M. Anita Madam, to present profound profile of Dr. L. Jagannathan Garu.
Good evening, all. Welcome you all to a 1 week online international workshop on mathematics, bridging ideas and innovations. It's my privilege to introduce today's resource person, Dr. L. Jagannathan Garu. Dr. L. Jagannathan sir is a senior professor of higher academic grade working in the School of Computer Science and Engineering, Vellore Institute of Technology, Chennai. He obtained his PhD from Indian Institute of Technology, Madras, with a specialization in theoretical computer science. He is a passionate teacher, having explored many learning methodologies like Z2A approach, project-based learning, research-based learning, flip the class, etc. His courses are oriented more towards triggering the young minds to think, and all his course related assessments are a real minds on sessions. With his 33 years of strong teaching experience as an educator, his present research focus is on AI for education. At present, he is working in a MBII funded project to develop AI tools to facilitate education in a more better way towards making the concept education for all reality. Professor L. Jagannathan sir is applauded by one and all with his best way of teaching for the last 3 decades. He published many research articles in journals and conferences. He took an active part in design and development of some new courses and centers of excellence and rendered valuable services to the college in different positions as head and dean. His inspiring character, motivational behavior, teaching abilities, research capabilities, extraordinary communication skills are additional qualities in him, apart from his goodness and vast experience in the field of education. Thank you.
Thank you, Anita Madam, for your nice introduction about Dr. L. Jagannathan Garu. Now I hand over the session to Dr. L. Jagannathan Garu. Sir, please.
Yeah. Hope the video is visible, I think. Video, audio, everything. Okay. So, good afternoon, all of you. And my sincere thanks.
Sir, please.
Yeah. Is it audible or not? Is it audible or not?
Sir, Jagannathan sir, we can start, sir.
Sir,
Yeah.
audible, sir, audible.
Audible. Okay.
Yes, sir.
Welcome to all of you, and thanks a lot for the opportunity given to me by the Bapatla Engineering College Maths Department. And whenever I speak about Maths Department BEC, I don't feel that entity is a separate entity. It is part and parcel of mine. So that whenever I say that I thank BEC means it is like a self-thanking actually. So usually we won't do that. So because the Bapatla Engineering College Maths Department has been embedded in me right from 1994. Really thanks a lot for it and the opportunity, everything. Now, the idea, the focus of this talk is going to be, I have given the mathematics of transformers, and in the whiteboard I wrote that introduction to LLMs and other things. Transformers are integral part of LLMs. Transformer came into the picture, a new architecture which is highly deployed in LLMs actually. And in LLM, what do they do actually? What is the main purpose of LLM is, this is roughly an agenda. What are the things which I will cover? I will be able to cover in a very slow pace, right from the mathematics of deep learning, mathematics of artificial neural network, and I will slowly develop the structure to transformer and end up with mathematics behind the transformer. For some reason, I don't want to rush up. For some reason, if you are not able to go to the third section or fourth section, the materials I'll pass on so that you can get the doubts. Because my idea is, if I give a deep introduction to this part, everything is contained in it. Only the functionality, how to make it out. The mathematics of deep learning is the same as the mathematics hidden behind transformer, everything. And what is LLM is, LLMs are made up of transformer architecture. So like that, so everything is interlinked. So I think that I'll try to, this is slightly a complex topic, but I'll try my level best to make it very simple. At least you get a feel, oh, this is the thing happening in the transformer. If that feel is got, then you can go and read the article. The certain famous articles I have downloaded for you. I'll show this to you actually, so that these things only, this mathematics cannot be understood just by oral explanation. But I can say that these are the things happening here, happening here, happening here. Then after that motivation, if you go through the document, the full mathematics can be experienced. Hope you are getting the point actually. So first thing what I do here is, what is the reason for you can replace the large language models as transformer also. There's nothing wrong in that, because it's an integral part of, like motors make the fan, motors make the pumping water, the motor is the core integral part of many mechanical devices. Like that, transformer has become the core integral part of many things actually. So now, first thing, we'll go for introduction to LLM, maybe for 15 or 20 minutes. After that, deep learning and other thing with illustration, I will make you understand what is the mathematics behind all that. After that, we go for large neural network, transformer architecture, and slowly make it out actually. And questions are welcome at every stage. If you don't feel free to ask any questions immediately, I have given my mail ID and the phone number. You can bombard me at any time actually. Even after 10 days, you told this is that and what is this, I am bound to explain to you, so don't worry. If there are questions, please make a note of it. Some people may feel shy of asking the question before the crowd, or some people may not get the question at all. When you go through this, all these things will be shared with you actually. So now, first thing, like in a theater, give a good listening actually. So now, neural networks, the machine learning models, and they came in the, so if the audio and video are not visible, please stop me there and there. Neural networks are a way to learn models from data. Models means training, the algorithm is going to be trained by the data. And how the neural network came into the picture is, they are inspired by the brain's network of neurons. And this concept originated in the 1940, and it was proved in 1980. For that, 2024 Physics Nobel Prize was awarded. Because there is no Nobel Prize for computer science and mathematics. For this idea, they awarded the Nobel Prize in 1980. They proved with the physical devices that with artificial neural network, we can learn many things. And neural networks have become inefficient till to 2017. And in 2017, the architecture called transformer came. Transformer is a new type of architecture. What do you mean by architecture? It is one frame, it is one new pipeline workflow. You do this work, step 1, step 2. It is a new algorithm, you can say that. Architecture means it is a new algorithm. You give the input, take the input and you give it to this module, and this module will find out the average of it. Like that, what are the process involved? Like futures, like modules, we call it actually. So now, first thing, before going into that, I am going to make it for which problem we can have this new neural network kind of thing. Suppose, I hope you are seeing my board. I think you are going to make a self-driving car. On what basis you will have an idea? First thing, you have to conceptualize it for making any cinema. What is the theme of the cinema? What is the concept? After discussing all this stuff only, they will get into the real shooting actually. In the same way, you are going to make a self-driving car. Okay. So what are the things, and your car is, please, this analogy will help a lot in understanding future ideas actually. Don't think that is going to be a story. For every architecture, there is an analogy story so that you can catch the point very easily. And this analogy is for deep learning. And what is the basis of why we are discussing deep learning? In the deep learning model is the base of the transformer. So if you understand the mathematics of deep learning, you can understand the mathematics of transformer in a more better way. Okay, now imagine you want to make a self-driving car that can drive on the highway. And what are the things you have done with the car is you have made the sensors on the front, back, and the left side, right side. So a sensor to detect the objects. And sensors are going to sensors will capture the objects, and what type of object we have to analyze in that. So car has proximity sensors on the front side. Sensors report 1 if there is an object before it, and it will report 0 when nothing is nearby. This is the work of a sensor, 0 or 1 binary actually. So now what is the thing we have here is, I'm able to see that?
Yes, sir.
So these are the things. Now, apart from the sensor, there should be some control. We call that as robotic actuators or robotic mechanism. Control there actually. That in the car, control is going to control the steering, brake, and accelerator. These are the 3 integral parts of any automatic vehicle. The steering for navigation, brakes for stopping, and accelerator for gaining speed, decreasing the speed actually. So yeah, what the sensors observe, that will be captured by this control mechanism, and accordingly they will apply the accelerator or brakes or steering. And accelerator, I am having if the control mechanism says 1, it is maximum acceleration, 0 means no acceleration, 0.5 means half acceleration, something like it. And brakes means full braking, no braking, 0 and 1. Steering means -1 means I have to steer left, and steer right means +1, and go straight is this one. So what is the thing intention here we do is, when the road is clear, you accelerate. Very good. If a car is in front of you, how do you know that a car is in front of you? You will get the sensor, the front sensor giving a signal as 1 to you. So if the car is in front of you, you slow down. If the car is too close on the left, what the driver do? He will steer the car to the right and change lane actually. So you avoid to the right if there is a car on your right actually. And you change this question mark is for codes actually. There is unnecessary question mark which I have missed out actually. If there is this is the thing. So driving involves, so now the automated driving involves what? A combination of action, steering, acceleration, braking. 3 actions are going to happen in that based on the data censored by the sensor. Okay, very good. So now the robotic mechanism controls SBA. So accelerator is 1.0, maximum acceleration, like that what I have told earlier actually. Hope you are getting the point. I think if you are not able to get the point, please don't give anything in the chat, unmute yourself and talk, because I can't have my view on the chat and other things. So I will be focusing on the slides actually. So now this is the typical thing. So there is a car. From the sensors I am getting front, all these things these are the inputs, and based on this I am making it. See, one thing you have to understand here is, see, you are able to see my cursor navigation from, this is the front sensor signal. So it gives, it is connected to the acceleration activator. So this is three things are activated. Getting the signals from front, back, and left and right, sensors, I am giving an instruction to the accelerator. In the same way, based on the 4 sensors input, there is an instruction going to brake. Based on the 4 things, there is an instruction going to the steering wheel. Am I correct or not? Now, what is the thing here is, what happens when so electrical current flows from all the sensor to all the robotic actuator, and the car simultaneously steers, accelerator, and everything. See, for example, based on the input, this accelerator will say that accelerate. Based on the same input, the brake will say stop. Based on the same input, this steering wheel say that go forward. So, going forward, braking, and accelerate fast, is it not contradictory? Then everything will be a mess. Are you able to understand the situation now? Any questions here? Because this is important for the future analogy. My idea is, I'm going to develop a circuit. This is something like a circuit. I call that circuit as a neural network, that's all. For my computation purpose, I'm going to call that as a neural network. Electronics people will call that as a circuit. Nothing wrong in that. Anyway, the connection matters actually. The information from the sensors are fed, and based on the thing, for example, if this front sensor is making seeing some objection, it is returning signal 1, then what it has to do, then it understands that there is a obstruction in the front, so it should not go straight. So the steering wheel should be made to left or right. Can you? So like that. Now, when simultaneously these 3 people, this front nodes, 3 people gives the instruction, what will happen is only a mess. You can have a mess of it. Am I correct or not? So what to do for this dilemma? So for that dilemma, so what I can do is, I can put a resistor or gate which will control put the resistor. What is the resistor's role is? It will control if the signals is an electrical signal. It will control the thing instead of sending full intensity signal. It will send half signals and other things, so that electricity can be between certain sensors and certain robotic actuator. I want electricity from front proximity sensor to the brakes and not to the steering wheel. That resistors will shut down. Like water is stopped in the dams using the shutters. That is the role played by the resistors actually. So this is the concept. So now, instead of resistor, gates also we can use. Gates can be closed and opened. It is a small circuit with AND gate, OR gate, NOR gate, exclusive OR. We have seen in the digital logic. If not, you can, sir, I don't know anything about gates. I don't know anything about the resistor. No problem. It is a mechanism to stop electricity signal at a particular place. That's all. That is more than enough for us to understand actually. So then where to put these resistors and gates actually? So for example, this is the sensor information. This is the actuate robotics command, and I include certain things in the middle. This is called hidden layer. This is in the circuit. I include certain things, and this will be the final outcome will be based on this hidden layer. We modify so that they activate with less energy. For example, if full energy of 1 is given, this resistors or gate will modify it. That's all. So that is happening here. So technically, this is an adjusting instrument. If I run with 100 km speed from the initial node to the end node, here the resistors are there to stop me. What they will do, if 3 people are approaching this, they will stop 2 and allow 1, because only one command can be given here, like that. So this is called a hidden layer. Now, how to process this thing? So one thing is the neural network we are able to understand, and the hidden layer we are able to. Hidden layer is because if you don't have the hidden layer, everything will be a mess here. Because every control mechanism, accelerator or brake, steering wheel gets the input. They give a command to the driver robo in a different way, so that finally it may become a mess. One fellow will say accelerate, another control will say brake, another fellow will say that go forward, something like it. So it is a mess. For that reason, we are introducing one layer in the middle that is called, we call that as a resistor or gate, whatever it is actually. So now what is the thing? So for this, we have a special, peculiar, good algorithm called back propagation algorithm in making guesses. That is, all combinations will come here. See, this mechanism will take all combinations of 4 combinations. For example, 4 combination means this front sensor can give 1, 0, 0, 2 power 4 combinations are there. So it has to take 2 power combination and give a final 1 single output. That is, it analyzes the front sensor, back sensor, side left sensor, right sensor, all this combination it analyzes, and it is going to give you one final answer what the car driver has to do. For that, we are having one good algorithm called deep learning. Deep learning is the major domain. And algorithm called back propagation. It makes the details. Now I'll give a brief introduction with the actual calculation mathematics of this thing. I'll download certain things. First thing, perceptron. I'll make it out. I'll make this out. 1 minute. I'll make this perceptron. This perceptron illustration, perceptron introduction. So now I'll show this. Are you able to see my written script? You are able to see my written script?
Sir, we are able to see it, sir.
Very good. Now. So now this back propagation algorithm I'll explain in a better way with this actually. 1 minute. I'll take the appropriate thing actually. 1 minute. Multi-layer perceptron illustration. Connection is not. I'll close the segment. 1 minute. I'll come out. Multi-layer perceptron introduction. MBII. Yeah, here it is. So now I just see here. This is the best example for it. I will download it and zoom it and show it to you. So this is the thing I want to tell mathematically, this network. This is one network actually. And I am giving the network input is x0, x1, x2. Analogy in the car example is sensor, sensor input from the front, back and other thing. There are 3 inputs for me and I am having this one. This one. This x0 and z0, they are called bias actually. Because that is the one which is going to help you adjust very well actually. This architecture is for back propagation algorithm. What is the mathematics behind the deep learning? That is the thing. First thing, you have to understand the layer. You have to understand the activation function. If you understand that, everything will be clear. And this is done with the help of a data set. Without a data set, this comes under the model called supervised learning. For example, x1, x2 are, If I give you 0, 0, I'll give 0, 0, 1, 1, 1, 0, 1, 1, 1, 0. So this is the data set for this purpose. And what I am going to do, how many input units are there? X1, X2 are the input units. Number of perceptron in hidden layer is 2. Perceptron is something, some processor you can understand in the neural network actually. The circles are perceptrons actually. This is the input layer. Hope you are able to see my navigation. Input layer, hidden layer, output layer. So now what I do here is we are going to calculate, we are going to have the initial value, and what the sigmoid function is one function. It looks like a S, and what is the sigmoid of A is equal to 1 by 1 power E minus A. The history derivation is totally mathematics. We are going to use the mathematics for it actually. So for everything there is an activation function, and see here how the updation, how this mathematics behind here is, this is due to the chain rule. Leibniz successive differentiation, we have the Leibniz chain rule. This is the direct application. Based on the chain rule only, we have this updation rule. So now here technically in any machine learning algorithm, these parameters are learned. Parameters are calculated. What are the parameters? W10, which connects X0 and Z1. Z1 is the name of the perceptron in the middle, and Z2. Like that I have made this actually. So now first thing, this is the very best example where the back propagation comes. From the iteration value, I can help you. I can tell you what we mean by back propagation. See here, y is equal to V0, Z0, V1, Z1, what V2, Z2. What actually we are doing in thing, y, what is the input for y? V0, V1, V2. These are the three inputs for y. Okay, very good. Now I am going to combine these three parameters into an algebraic equation. This like a coefficient. V0 is unknown. V0 is the thing which we have to find out. Z1, V0, Z1, V0, Z0. Z0 is called bias. Always this Z0 will be like your 1. For example, if we propose a quadratic equation, ax square plus bx plus c. C is called the bias here. Based on the values, I will adjust the constant term actually. See, for example, I will tell you this in the board actually. I will go to the board. Where is my board? 1 minute. Auto draw. Here, see here. This is the place where I can make it out. For example, I am having ax square plus bx plus c. This is the equation. Now I am having the input x is equal to 4. And the real value, and what I am making it, this is equal to y. Something like it. This is equal to y. And y is equal to 7. Now, what I am going to do, ax square, I have to find out ABC. I have to find out ABC such that y is equal to 7 is obtained. Y is equal to 7 is obtained for x is equal to 4. And when x is equal to 4, 16a, 4 square 16a plus 4b plus c is equal to how much you got to make it out. And suppose what the people will do, they will calculate a and b, and accordingly they will adjust the c. The c is called the bias component. This b, after that, this c will be a, b, c are the three things we have to make it out. See here, we have to calculate based. In the supervised learning, the data set tells you what is 7 actually. 7 is the actual value. So I have to adjust this A, B, C to reach the 7. And many times they will be interested in adjusting this bias only because that is free from the variable actually. So it is easy to adjust. Adjust that C in compared to that A and B. So this is called bias factor. A bias means which is in our control. And actually we can't give a random values. And this is for the input I have given. Data set will have millions of input. So I have to find out the values of ABC with reference to the input. So in this data set, I am having 4 inputs. In this data set, I am having 4 inputs. So I have to find out the values of A and W1 X1, W2 X2 plus R is equal to this. R is your output actually. So now coming back to the thing, I am making a proposition connecting V0, V1, V2 with Z0, Z1, Z2. So is equal to V0 Z1 plus V1 Z1 plus V2 Z2. Then I will calculate this value, and what I obtained here, I will apply the sigmoid. Sigmoid, what is the purpose is, this equation, I mean, see here, this X0, X1, X2 is the initial input, and this gives the, sends the signals to Z1. From X0, there is a signal, X1, there is a signal, X2, there is a signal. Okay, very good. Then what Z1 does, see, for example, in any neural network, what it will do, I'll put a neural network diagram now. Hope all of you are able to follow. I think, though it may be slow, it is worth, I think, actually. Again, I'm telling, if I'm not able to cover certain things, I will share the document so that you can ask the doubts anytime to me, actually. Now, see here, in a network, what is the thing it will do? This is the input. Input perceptron, they will call. Okay. Bear with me for my shabby calculation, shabby drawing. And this I call as Y. And this I call that as X0. Input variables are 2. X0, X1, X2. And what I do here is, I have to connect this. What I do by this connection is, I am making a proposition that Y is equal to, I am making this proposition Y is equal to W0 X0 plus W1 X1 plus W2 X2. This I am making it actually. So it will calculate all these things. After that, we will apply an activation function. Activation function means there are many standard, that is, this bigger value is being transformed to some other value. ReLU is rectilinear unit. When that is, if you give it will give the positive values actually. So if we give you -1 to this, it will return 0. If you give 4 to this, it will give 4. Like your positive function, which we use in the standard mathematics, like that actually. And logistic sigmoid function, what it will return? Sigmoid function is having a special property. That is the derivative S of 1 minus S is the derivative itself actually. So for example, sigmoid of 4 is equal to 1 over 1 plus e power minus e power 4. And this value ranges between 0 and 1. And sometimes softmax will be there. Softmax, when there are multiple output, softmax, that is a very powerful activation unit in your, transformer architecture. What do you mean by softmax? I'll tell you. So this is the basic work of anything. Now I'll make a start over. And in the softmax, I'll explain softmax. These are the measures to make it very small so that we can get the classification. Softmax of 1, 2, 3, 1, 2, 3, 4. This is multiple. Here in this in this network, I showed only one. There is only one output. Now, what is the thing? One softmax is 1 over plus 1 plus 2 plus 3. I'm sorry. Plus 3 plus 4. That is is equal to 1 over 5, 9. 1 over 9. For the second thing, what I do here is 2 by 9. Third thing is 3 by 9. And fourth thing is 4 by 9. So these are these outputs are converted into a probabilistic like values using softmax. The thing is, so now coming back to the thing, so what is the basic thing is, it gets the input, and there is an output, and connection is done. This is the way neural network signals are being done. And if this is W, if inputs are called X0, X1, X2, and this output will be equal to W0 X0 plus W1 X1 plus W2 X1, basic linear combination. That's all. All this deep learning works based on the linear combination of the parameters involved. And how many parameters are here? There are three. The W0 is one parameter, W1 is one parameter, W2 is another parameter. Three parameters are involved. As I tell you, what are the unknowns here? I'll tell you y is equal to W0 X0 plus W1 X1 plus W2 X2. So now there are three parameters. What are the parameters? This is one parameter, this is one parameter, X1 is one parameter, X2 is parameter. This X0 is the constant term, W0 is the constant term, so always it will be taken as 1. This is called this W. So we have to find out W0, W1, W, three parameters we have to find out. Like this in LLM, 17 billion parameters are being computed. 17 billion parameters are computed. So only for that, if you know the deep learning architecture, you can understand that architecture well. Just I'll go back to my example. So now, what are the inputs? X1, X1, X0, X1, X2, and how many parameters are there? W10, W20, W21, and W11, W12, W22. So here 6 parameters, here 3. Totally 9 parameters are there in this architecture. So now equations for y is equal to this. Z1 is equal to sigmoid of y is Z1. Z1 is a combination of X0, X1, X2. So I put the coefficient. So sigmoid of W0, X0. What is the corresponding weight? We call this weight or parameter. Any name you can call this. And these are the unknowns which you have to calculate. W10 X0 plus W11 X1 plus W12 X2. After calculating this is the sigmoid function. Sigmoid function is, if you draw the graph for sigmoid, it will look like a S. Lying between zeros and 1. Never it will be 1, never it will be 0. So now it is a sigmoid. So 1 by 1 plus e power minus thing. That is the output given by this sigmoid. In the same way, so every perceptron puts the linear combination of the inputs it takes, put along with the coefficient. The coefficients are called weights or parameter, and then applies an activation function and gives the output. This is clear or not? And these three neurons give, the output given by Z0, Z1, Z2 is the input for this neuron. Like this, we are having 10 power 11 neurons in our thing. Now we are talking about 9 neurons with this figure actually. 10 power 11 neurons are there in our doing all this business. That is the thing which actuates. When I see a snake, it observes, the sensor observes the snake and activates my brain, and brain gives a signal to my hand or leg to run off from the place based on a complex mechanism called neural network. This is artificial neural network. This is the real neural network. That's all. So now Z1, Z2, this combination. So how to update the values? So you write, this is the output of a concept called gradient descent. Gradient descent is the outcome of that is maxima minima, which we have studied in your 12th class for function of one variable or function of several variables. In the here, we are going to find out the minima, because which we want to minimize. When, for example, if there is an error, for example, this is the thing. I will go to the blackboard again. I'll go to the, for example, I told you, I want to calculate. This is my hypothesis. Are you able to follow? Are you able to follow? AX1. AX1, X1 plus, I'll put it this way, W0, X0 plus W1, X1 plus W2, X2. This is the thing. And X1 is the input value. X1 is equal to 2. X2 is equal to 4. And real value of, because since there is a data set, real value of y is 4. Now what is the task? To calculate W0, W1, W2 such that Y value is 7. This is the task. Can you get the point? Now, if I give x1, x2, for example, initially I will assume that W0 is equal to 1. W1 is equal to 2. W2 is equal to 1. So what is the predicted value? Y hat is equal to, y hat means predicted value. Y hat is equal to, I am having 1, x0 is always 1. So W0 x1 is 1 plus W1 is 2 and x1 is 2. So it is 4 plus W2 x2. The W2 is 1, x2 is 4. So it is going to be 4. I am getting 9 with my initial value. So I have to adjust all these parameters. And what is the error here? Error is 2 here because real value is, error is 9 minus 7. That is equal to 2 here actually. So now this error I want to minimize. Because how can I say that the error is 2 actually? Because the original value is 7. My prediction, my values are giving 9. So 9 minus 7 is equal to 2. That is the real concept actually. So this error I want to minimize. For that, there is a good concept in mathematics called gradient descent. Let me not go into the gradient descent. The gradient descent formula is this actually. We are just borrowing, I am not deriving. V0 is equal to, that is I am going to update the parameter of V0, old value plus eta. Eta is like a control valve. We cannot, the value ranges from 0 to 1. If I make it, if I make it 0, then there is no learning happening. Old value, old iteration value will be the same iteration value. If it is, when this will be activated, for example, RT is the original value, YT is the predicted value. If these two values are same, then there is, this value is correct. There is no need to change it out actually. Like that, V0, V1, V2, I have written the formula. This W10 calculation is due to this, hope you see my cursor movement. This is due to the chains rule, the successive derivation chain rule in mathematics, partial derivative chain rule. Dou z by dou, dou z by dou x is equal to dou z by dou y into dou y by dou x and other things. The same concept. This is the algorithmic interpretation of the original thing actually. So W11, W12, W1, like that, for all the things I have made it out. Now I am doing the initial calculation. Choose initial value, anything you can choose. Eta is equal to 0.5 and all the initial value I have made it 0. And all this. So V0 is 0, V1 0, V2 0, V1 like that, everything is 0. So first iteration is, I am going to, what is the thing? First data set. What is this data set? I have given, there is a data set for everything. 0, 0, 0. This, when you give input x1, 0. When you give input x2 as 0, output is 0. When you give input as 0, our input is 1, like that actually. So I am taking 0, 0 as 0 here actually. So now I am making this here. So I am taking that 0, 0, x1 is equal to 0, x2 is equal to 0, r is equal to 0. Z1 is a sigmoid function. Sigmoid function of what? As I told, I have written that sigma, Z1 is the sigmoid. First I have to calculate Z1, I have to calculate Z2. Z0 is always 1, no problem. That is called a constant term, like we call as a technically bias also. Then we have to calculate Z1, Z2. Z1, Z2 is the input for Y. I am explaining the deep learning architecture. So now the mathematics here is what? Just Z1 is equal to sigmoid of this. I calculate sigmoid of 0 is what? 1 by 1 plus e power minus 0. That is equal to 1 by 2, 0.5. Z2 is the same way you have to calculate. This is also coming as 0.5. Z2 I am just using the equation which I wrote here. What is Y actually? Y is equal to V0 Z0 plus V1 Z1 V2 Z2. So here what is the value of Y? Real value of Y is 0. Predicted value of Y is 0. So there is no change in the prediction. All the updation rules involved, since it is 0, there is no updation, because in the V1, V2 there is no updation. because what is the thing? V0, V1 involves RT minus YT. RT minus YT is 0. So that is the thing here. So now what I do here is, I am calculating Y, and after that I am taking the next row in the data set. See the next row in the data set, 0, 1, 0, 1 gives 1 actually. So now 0, 1 gives 1. 0, 1 gives 1. I am substituting, I am calculating the values of the same way, Z1, Z2, Y I am calculating, and there is a here, Y is in Z2 is 0.5, and V0 Z0 plus V1 Z1, it V2 Z2. So 0 star this thing, Y is equal to, there is a difference between the predicted. So RT minus YT is 0, so there is an updation for V0. So V0 is going 0.5, V0, V2, all this manual calculation you can understand. So now, after V1, V2, I am going back to W10, W11, W12, W20, W22. So now at the end of the first initial iteration, what was the thing we had? This is the first iteration is 0, 0. All these values were 0, 0, 0, 0, 0, 0 and other things. Then after that, in the second iteration, what are the values you are getting? In the second iteration, again all 0 because there is no updation. In the third iteration, see here, some values have got changed. V0 has become 0.5, V1 has become 0.25, V2 has become 0.25 and other things. Then, so now at the end of the second iteration, this is the thing. Now, here, which is the very purpose of this back propagation algorithm is, what is back propagation? In the W0 calculation, see here, in the W1, W0 calculation, RT minus YT is a part. What is RT minus YT? In this thing, RT minus YT, this Y is the value predicted by the system. R is this value. R is this last column, true value as in the data set. So now, in this Y, this is the thing. So now, if there is an error of 2 or 3 units, it is coming down, it is getting distributed, and the work is recalculated. So which is coming back forward, back propagation, which is coming at the back propagation, error made here. How do you know that error made here? In all the equation, RT minus YT is here. See, find out, RT minus YT is the error made by the whole drama. So RT minus YT like that actually. Now that is being calculated, again updated. So then when the second iteration, see here, if there is an error here, so it goes on like this actually. So W21, at the end of the second iteration, the values have become like this. Then I have to do this till the error is getting minimized. Sir, even if you do the 10,000 times or 20,000 times, error is not getting minimized, then that means what? You can stop it. Okay, this is the error nature, so I can't make it out. And so that how long you can continue this calculation till till there is a convergence in the value. Even if you do it again and again, the same value is coming. Then the convergence is obtained, then the iteration stops. If the convergence doesn't happen in the machine learning, you can do up to 10,000 iteration and take the values actually. These parameters are called the features of this actually. At the end of the third iteration, like that is goes. This is the typical example of deep learning architecture. Can you get the point? And what is the algorithm here used? Back propagation algorithm. And which is being propagated down. If an error happens at the end, for example, in our illustration, we saw the predicted value is 9 and the real value is 7. 9 minus 7, 2 is getting distributed among all the nodes, so that everyone will adjust himself to meet the real value actually. So that is the concept. Like where I do, here, this is the thing. For example, this error is 2. Now again I do the calculation. Error is coming, so that based on that, W0, W1, W2 will get a reiteration value. So that this drama goes on since the error is minimum. So here, which is called the back propagation, error is propagated back. And how do you know that error is propagated back? See this in the formula. RT minus YT is happening in all the things. RT minus YT is the error. See here, RT minus YT is the error happening. In all the equations of the updation iterative rules, I am having, see here, RT minus YT happens in all the calculation. The error made at the topmost node is being distributed, propagated back to each node for further iteration. So that, and this drama goes till this term becomes 0. If this term becomes 0, then the W11 will be equal to W11 plus 0. That's all. So this is called the back propagation. This is a very powerful two concept here. Gradient descent is one important concept. Based on that only this weights have come. This information has come. I'll give gradient descent. Let me go for, because gradient descent will take more time actually. So now I'll go back to my main discussion. So now here I'll come to my old discussion, the deep learning. So this is the thing I want to explain. An algorithm called back propagation is reasonably good at making guesses about how to change the configuration of the circuit. Configuration of the circuit means calculation of the weight parameters actually. So I have not given the details of the thing. I have given the illustration for you and go back to the main thing actually. Now, so now what is the thing? Coming back to the thing, deep learning. Now, coming to the language model. Here we are getting into the situation, transformer. For example, in the example of the car, we are trying to get our neural network to perform the behavior that was consistent with our data. That is, what is the value of the unknown with reference to the data set? That is the thing we calculate. Data set is the real true, ground truth for us actually. We're asking, we create instead of circuit, we call that as a neural network actually. So now, what is being done in the language model? In the language model, only one thing is done. This is what you can use the ChatGPT or Gemini for anything, for any purpose. But what is being done here is just here. What is being done in this is given X now, given X, given English sentence, I go to, what if given I go to, what will be the next sentence? That is, given n words, this is the basic work of any LLM, this is the basic work of any transformer based on the data set. Given n data, n record, given n words, predict the n plus 1th word. N plus 1th word. How you are, that is the basic workout. You use the ChatGPT for chit-chatting with you, you use the ChatGPT for writing in a research paper for you, you do the ChatGPT with any analytics for you, anything you can do it. But what is here is, this is here, core work of any LLM model is, given n words, it is going to predict the n plus 1th word. Can you get the point? Based on this, philosophy only, the whole LLMs work, and background architecture behind the LLM is transformer. Why LLMs got speeded up now? Earlier, in 2017, we got a very good paper. Attention is all the thing you need, by Vaswani from Google Research Group, that made the drama very clear. Earlier, earlier also LLMs were there, but that was not working very sincerely because of this attention mechanism. Attention mechanism means, see that words attention, transformer, or we can have this, both are synonyms actually. So transformer model gave a very good insight how to compute this in a faster parallel way. Only after 2017, this type of architecture improved, and we have now got LLMs. Many LLM, now once that OpenAI ChatGPT LLM has come, it's running with the 5th version, and Gemini 3rd version 3.0. Like that, everything started. So now, this car analogy I am going to compare with this language model. How? So what to do for it? So when we did we were trying to get our neuron to perform the behavior that was consistent with our data. We can treat the language in the same way. We can look at the text written by human and wonder whether a circuit or a network could produce a sequence of words that looks like the sequences of words that humans tend to produce. Now our sensors fire means sensors send the input. We see words and our output mechanism are words too. For example, this is the thing. This is the thing. We are trying to create a circuit, means instead of circuit, mathematically they call that as a neural network. That guesses an output word given a bunch of, for example, once upon. What will be the next word? Once upon a time, once upon a forest, anything may be. So it should be fill in the blanks, time, but not armadillo. Armadillo is the name of an animal actually. This was given in the paper, so I am carrying the same example. So now this is something like a conditional probability. Mathematically, PR, probability of time, given the earlier three words as once upon, what is the probability of P of the word time? The question mark, you can treat that as a quotes actually. Given a bunch of words, once, upon, and a. We would expect a good language model to produce a higher probability for the word time than the word armadillo. Armadillo, or once upon a school, once upon a university, once upon Chennai, once upon Bapatla, like that. If we make it out for each thing, we'll calculate this conditional probability. So this probability of nth word given n minus 1 word is the basic work of any LLM. So how we are going to achieve it? That's the thing. Compute the probability of the nth word in a sequence given all the words that come before it, like that actually. So now, for example, just think about another analogy I am giving. Think of an old fashioned typewriter. In the typewriter, for every actor, there will be a striker actually. D, A, 1, 2, 3 and other things actually. Now, different striker arm for each letter. We have a striker for each word. Assume that your typewriter is having a striker for each letter. Hope everyone, the keyboard is the typewriter actually. When I type W, there is a striker W which makes an impression on the paper. That was the thing old typewriter had actually. So if the English language has 50,000 words, then this is a big typewriter. Instead of a network for the car, think of a similar network except top of a circuit. That is, what is the thing is, I am giving all the inputs. I want to know what is the output for it. See here. So like that, given all the sensor input, how that car made the thing. It gives a clear-cut instruction, either brake or accelerate or turn left, turn right or stop or something like that. So now, instead of a network, why we are having, if the English language have 50,000 words, for example, I go to dash. We have to calculate the probability of all the 50,000 words here. And unfortunately, English language, we can't confine that it has only 50,000 words actually. So now, what we have to do, we should have a sensor for all the 50,000 words actually. I want to know whether this will fit, this will fit, this will fit, each one detecting the presence of different input word. So it is picking a single structure arm, gets the highest electrical signal, and that is the word that is what I am here. What is the thing analogy to the car example? I go to dash. I want to make the input I go to. What is the output? I want to know it. What will be the next word predicted by the transformer or LLM actually. So now for that reason, what I will do, I will create an analogy like this. This is the thing. That is all the inputs I give here. And I want to know whether this word is possible, 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 this word is possible. Like that, I give all the words actually. And I connect like we connected in the car example or in the backpropagation algorithm example. So I connected and I give one fellow will say guardian, one fellow will say king, another fellow like that actually. Now there is a confusion here. So this is a big network, but it is full of complexity. So if I want to do the once upon, predict the dash, fill in the blanks, I need to sense the word, which word is in the 3 of the position. So if I want to make this dash correctly, it is just a fill in the blanks. LLM does the fill in the blank work, not even any other thing. But it is doing the fill in the blanks every time. Once upon a time, comma, there was a king. So for every word, it predicting the next word and it generates the whole answer for our query. So if I want to do once upon a thing, I need to sense which word is in each of the 3 input position. So what is the thing? First position is 1. Once upon means immediately we will be understanding time, because we have seen many words in our story like that. Once upon a time, there lived a king, there lived a snake or something like that. So now in this case, what is the thing? I will need 50,000 into 3 senses, because I want to know the position. Once appears in the first position, upon appears in the second position, A appears in the third position. So now what I have to have it here is, how many sensor I have to make it out? 50,000 words in 3 positions. So 1,50,000 sensor. So now what is the thing is, for 50,000 striker arms, will have 1,50,000 into 50,000 again. So it will be 7.5 billion wires actually. So most complex network is the transformer architecture. So now the here is, just to make one word predicting, given 3 words, it has to do all the computation. And even if you do all the computation, there is a mess in it, because everyone will start predicting something. Like in the car example we saw, the one output was telling brake, another output was telling accelerate, another output was telling turn right. Then which will be the correct thing? So this type of architecture fumbles now. So the thing is, now as of now, the language models can take 4,000 words at a time. And at a time, with a bag of 30, that is at a time you can give 32,000 words at present actually. And it processes all this, how much huge you can make it up. Only for that reason, in this deep learning architecture which I illustrated, we were calculating only 9 parameters. But what it is, here it is how many parameters? 7. For every wire there is a parameter. For every line connecting the 2 sensors, I had a parameter actually. So as of now, most large language can take 4,000 parameters. So for what we do here is, so it is going to be a mess of it. For that reason, what we have to break. Now what is the thing? It is very mess of it. So can I break that into 2? That was one suggestion came. So now what I do, what we heard, we have the concept called encoder. Transformer is made up of encoder and decoder. For example, what is this thing? The king sat on the dash. Queen sat on the, this is another example. Princess sat on the, regent sat on the. So what a reasonable guess for all the things will be thrown, or can be toilet also, it will be. So which is to say that I might, now if it is thrown, I have to connect all this king, queen, princess, regent to the throne actually. Instead of keeping them separate, what is the common word for this? Royal people, king, queen, princess, regents are called royal people. So what I do that, I will just make it, which is, I might not need separate wires between the king and throne, because I want to reduce the complexity. How many, hope you are getting this calculation, how this, for guessing the 3 words, assume that there are 50,000 English words, and which word is in each of the 3 positions. For example, once upon A upon once A upon, all these 3 combination, 3 factorial combination will be tested, and it will be, for each thing, for each position, there will be 50,000 guesses. So it will be 1,50,000 sensors, and this will be up for each of the sensor, it gives a word, and what is the likely output? It will be 50,000 words. One word from each thing will be the output. See here, the top layer is the thing. Once upon a time, this 50,000 will come here. So now, to reduce that, I am thinking about a thing called encoder. A reasonable for which is to say that I would not say, instead I would be great if I had something that royalty. So what I can do, king, queen, prince, princess and regent, I can connect it to royalty. So now what I can do here is, so set up one circuit that takes 50,000 word sensor and maps to some smaller set of outputs like king, queen, princess, they are mapped to one word royal instead of 50,000. So like that, what I can do here, this will give, this is something like it. That is, I am giving this input and output I am getting only 256 of this. So earlier, how much was the output? 50,000. Because for everything, what is the thing we do here is, the king sat on the throne. Those there will be a wire connecting king and the throne. Queen sat on the throne, there will be a wire connecting queen and the throne. Princess sat on the throne, there will be a wire connecting princess and other thing. Regent sat on the throne, there will be a wire connecting all these things. Instead of it, what I do here, king, queen, princess, I connect with the royal. Sir, how do you know that it is royal? The calculation are based on this concept. Mathematics has got evolved. Just wait for the climax. So now it will be in reality just 26. I am making it. So what was the thing? So previously one word required every word 50,000 sensors. Now we have one thing. Now it will be like this actually. All this inputs are just see here. All this input encode. This is called encoder. Squishing 50. This is encoder is a what is the thing? Backpropagation network. This network is called feed forward. Inputs are moving from bottom to top. Error is coming down from the top to bottom. So the people will call that as feed forward network or fully connected network. And the algorithm which is used here is backpropagation algorithm. With a backpropagation means which is propagated back, errors are propagated back actually. So this is the thing. Now what is the thing? I want the answer for it. Now I have connected with all the royalty. From royalty, I have to get the answer for like a throne and other things actually. So now once king, queen, princess are connected to royalty, then the sat on, this gives a thing, most probably all will be connected to throne, like that instead of toilet. Royalty, sat on the toilet may not be an apt word actually. So like that, so set up one, what was the thing here? So one word, I have connected all these things, so encoder. Now comes the decoder. So, but the encoder does not tell which word should come next. It has connected king, queen, princess, regent to the, what do you call that, royalty. From royalty, somebody should take the forward. That is called decoder. Decoder is again another fully forward network that I have demonstrated deep learning architecture. Decoder is another circuit that takes 256 numbers, making up the encoding and activates the original 50,000, one for each word. Then this is the thing encoder. So decoders look the input given by the encoder architecture is given to the decoder, and once this is then expanding 256 values in the encoding into activation values for the 50,000 strike around. Each one word activates the highest. So we have to find out which word will have the highest probability. That will be the throne here actually. So this encoder and decoder put together look like that. Encoder, it is just a decoder sitting on the top of the encoder. Input, this is something similar to this type of culture. I'll tell you what is the thing here from my example. See here, this is your input, this is your encoder, this is your decoder. So this is you are giving all the three ones upon a time, and 256 inputs are given, and among these 256 inputs, it is checking for each 50,000 word. Assuming that English language has 50,000 words, it is going to identify which value is more. So this encoder decoder architecture is one important game. Of course, in encoder architecture were also before, transformer came into the picture. Now, but with this encoder architecture, they introduced a new mechanism called self-attention mechanism, attention mechanism. That is the main thing climax actually. So now, so this something like a encoder decoder you should have understood here. Now the number of parameters have come down actually. So earlier it was something very high. Now it is only 256 million parameters actually. So for one word input, producing one word output, we should have how many inputs and how many calculations. See the thing. Heavy computation is being done by LLM actually. And that is giving another thing to worry. When this heavy computation are done with the server, the cooling, they have to spend huge amount of water actually. So now, of course, that is the environmental another issue because of the advent of AI that is also happening up actually. Now, how do we know what encoding for each word is best? We think king, princess, queen, I know it, so I connected to royalty. So encoder is the best representative for that group. Encoder, what it does actually, it is connecting analogy. It is connecting a group of words to a particular word, because 50,000 words should be compressed to 256 words. On what way it is going to do actually? How do we know that encoding for king should be similar to the encoding for Q? The same question. The question mark has quotes actually instead of, because in my LaTeX that has got corrupted. So this, when I put quotes, it's coming as question mark. So now this, for that reason only, the self-supervision or self-attention mechanism came into the picture. As a thought experiment, consider an encoder-decoder network that should take in a single word and produce the exact same word as an output. So now what is the thing we have to make it out? So same word. So now, suppose I'll share with you. This is the thing what we did in the case of your deep learning architecture, the errors and other things actually. For example, put in the word of king and a single sensor sends its electrical signal through then partially runs on 256 value. If the encoding is right, then the decoder will send the highest electrical signal to the king. So if king is connected to royalty, royalty is connected to this thing. So suppose the striker round for king gets 0.51, 0.1. The intensity of the striking rate, the value of that striker rate is equivalent to the intensity of, value of the parameter. So don't even, if it is armadillo, it will be the difference between 1.0 is an error, and I can use back propagation. I told you, when the error is there, it will come to make some changes to the decoder and encoder. It comes fully down. We saw in the RT minus YT, in every updation, RT minus YT happens. So that is the very much beauty of this encoder architecture actually. Next, another technique they do in the transformer architecture. So here what we have done, we have made encoder and decoder architecture actually. Now masking a sequence. So now, I want to know, for example, what I do here is, I'll give one example, this masking. What is this masking? I want to make this actually. So what they first they will want to know how these things are connected. So it will mask certain word. For example, it will mask this and it will try to guess it out. And how I is here, going is here. What should be this word? Like predicting this word. Like predicting the n+1th word, taking the nth word, it is going to predict first word it is giving, and second word it is going to predict. After that, based on the second word, it is going to predict this, that is after masking. For example, if I mask it out, what am I going to do? If I mask it out, this I want to fill up this blank. What will be the probable word for it? I, am, went, like that. Then based on this prediction, it will bring going into the picture. So I went going will not be apt word. I slept going, I won't be an apt word. So it will find out which word is making it. So if am is correctly predicted, I am going. That will be guessed out actually. So like that, it masks each and word so that it gets the sequence correctly. Based on this idea, it is going to predict the fourth word actually. First, you mask the first word. You mask the second word. Make a good prediction of the second word. And mask the third word. Make the prediction. Like that, it is based on this data, it is going to. That is called masking. So that will add the values. I will get tired of drawing a lot of, so I will just draw red lines to mean lots and lots of connection between everything above below. So now what I do here is this 0, 0, 0 is instead. Now what I have done here is, instead of sentences in the English word, I have given the vectors actually. Every word is transformed into a number for this calculation, because after all, deep learning does the calculation only with the number, not with the strings and other things. So now I'll go back to the slides. Are you able to follow? Is it audible? So if the above thought is clear, sir. The idea of mask is to take in a sequence of words and generate a sequence. One of the words in the input and the output are blanked out. The mask I am making the, instead of dash, the sat on the throne. We know that it is king. We want to know whether how does it perform. The network guesses all the words. Well, it is pretty easy to guess the unmasked words. We only really care about the network guess about the masked word. That is, that is based on the prediction, because we know that it is king. The king sat on the throne. So what we want to know, once this throne is there, I want to mask it out so that whether king fits correctly or not. After predicting throne, I want to check by masking that whether that particular word will be apt or not. So the network guesses all the words for mask. So I am making correction of that. That is the mask language model actually. So now mask around having network is different words in different places. I am masking it, the queen masking it, the queen sat masking it, the queen sat on mask, this is called, I am generating one by one. This is the way that LLMs or transformer architecture works actually. Now, now coming back to the transformers, I'll show a transformer thing. This is the basic paper. Attention is all you need by Vaswani et al. A transformer is a particular type of deep learning model. Now we understood the mathematics of deep learning that transform the encoding in a particular way that makes it easier to guess the blanked out word. At the heart of transformer is the classical encoder-decoder network. The encoder does a very standard encoding process. So now, here the self-attention is very important. Certain words in a sequence are related to other words. That is, the whole meaning of the sentence is based on the contextuality. Self-attention, sir. Consider the sentence, the alien landed on the earth because it needed to hide on a planet. Now, if we were to mask out the second word, alien, and ask a neural network to guess the word, it would have better a shot because the words like landed and earth actually. So now, if I'm asking the second word alien and ask a neural network means our deep learning architecture. To guess the word, it would have a better shot because of words landed. Likewise, if we masked out it and ask the network to guess the word, the presence of word alien might make it more likely to prefer it over he or she. Because alien has come. So if we mask it, what will be the prediction? It alone, because alien is not masculine or feminine gender. So like that, this mask, that is what I do here is, this in the same sentence, every word is compared with every other word to know their relationship. That is the value matrix. Core matrix will be calculating based on the QKV actually. So based on that, relationship between each, that is, I am focusing on me. That is called self-attention. So now words attend to other words because they capture some sort of relationship. The relationship is not necessarily known. It can be resolving pronouns. It can be verb or something. So like that. So mathematics of self-attention is main is that a transformer learns which words in an input sequence are related and then creates a new encoding for each position in the input sequence, merging all the words. For example, for this work, because each word is encoded as a list of number. Alien, I am making one embedded vector. This embedding is a very powerful mechanism in AI culture, machine learning culture. What is embedding is, I want to represent each word in a space. It can be a 50,000 dimensional space. For example, here I have made it out 0.1, 0.3, masking the word 0.4. This is the way I want to guess the vector of this actually, the missing number. Each word is encoded as a list of number. If alien is equal to this and landed is this vector and earth is, then the second word position might be encoded as sum of all these encoding, which itself does not correspond to embed, captures pieces of all the word. So now what is, I'll go back to the thing, how self-attention happens in 3 stages. We encode each word in the input sequence as normal. Encoding, just assume that encoding is based on position also. I went to school. I can be encoded as 1. Went as 2. 2 as 3. And school as 4. And if it is a 3 dimension, 1, 0, 0, 0, 2, 0, 0. And what do you call that? Go will be 0, 0, 3, 0, like that actually. Now we encode each word in the input sequence. We encode each word means encoding is what? It is a neural network. So we run that again and again. We run a second round of encoding. Many times we run it. Each undergoes different encoding process, so they all become different. We call one a query. For each word we raise a query, one a key and one a value v. Think of a hash table like that. Actually, this is the thing. Query, key, value, self-attention actually. So match the query against each key. I'm creating a hash table like this actually for self-attention, coming back to the thing, and query is this, keys is this, values is this, and 1% of this is the calculation. I'll show it again actually. For each word position, we are going to take the Q encoding, K encoding, compute the similarity. We use something called it's a dot product or something cosine similarity. Every word in a list of this, we call this matrix as a self-attention score. For example, position 1, position 2, position 3. Query matrix, I am making position 0, 1, 0. This is the matrix. How much encoded word in one position attends the encoded word. The query position 1 word and position 2 word are having strong relationship. And position 2 is having a strong relationship with the 3. Position 3 is having a strong relationship with 1. Like that actually. This gives because of the self-attention mechanism. So now, this is the position 1 and other things. Each row is an encoding word in the thing. So now, now I'll go to the simple example. I'll go to the working part of it. For example, I'll prepare one thing, 1 minute. So now I'll go for this one. And before that, I'll show that architecture. This is the thing. I'll make it out, the final architecture. This is one famous taken from the hands-on large language model, on chapter 3 of it. I'll share it with you actually. So now we are using this transformer model for translation. Now, sir, how come you did something guessing, given 3 words and you are going to predict the 4th word? How come you are able to come immediately to the translation? The data set will have the translation of all the English sentence and to the German. So, for example, this is I have given in French actually, and this transformer is going to translate this output into an English. So, for what is the thing we are going to do here is, we are in the back for every deep learning architecture there should be a data set. Like we had a data set here. We had a data set here. We will have a data set like this. I'll show it in the auto draw also. For example, there will be a table. This will be the source language. Something will be in the source language. English. This is the source language. This is the English translation. And this English translation, like that, all the translated words will be there as a data set. Please understand, this runs to millions of records. It can be a 1-word sentence or 2-word sentence, a sentence having 10 words, 15 words, 25 words, 30 words, all combination. This is something like, for example, I'll tell you a famous story. This is, for example, assume that you don't know what is addition of 2 numbers. Assume that you don't know the addition of 2 numbers. So now what I do is, I want to teach you how to add 2 numbers, or I want to make a deep learning architecture to add 2 numbers. So what I can do here is, x1, x2 will be there. We don't know that. I am making an output of it. You don't know anything. I am making a data set with this. Like that. I'll have 100-digit number, 300-digit number, something, 10 million data, 10 million rows I created actually. Now, I don't know the addition, but finally you are asking the question, what is the addition of 14 plus 14? I can train this model. I can have a deep learning architecture and say 14 plus 14 is equal to 28. I can say or not. This is the way. So now for the translation architecture, we will have the translation architecture, we will have, where are we left out actually? No, yeah, here. So for the translation architecture, we will have a data set. So given the input, it will take this thing and it will give an output. So now how the transformer is made up of, just now we saw the bigger network, bigger circuit is broken into encoder and decoder from an analog example. 50,000 inputs you give and it is mapped to 256, like you have the king, queen, princess, it is mapped actually. So then 256 is fed into another neural network, big deep learning backpropagation algorithm, like that it goes actually. Encoders to decoders, it outputs actually. So this is how could this know this language translation and other thing? Because you have provided a data set as if just now I provided a data set for addition of two numbers. I don't require addition. I don't know how to add 4-digit number, single unit digits you carry and carry over, and all this drama only required actually. You put, if one person knows addition, let him prepare all the data set, all one big table in which millions of rows are there. Each row carries x1 and x2 and adds like this actually. Can you get the point? Now, this input, since it is trained with the input, because how did we train the this mapping? How did, for every input we did the training? See here, in item 0, 1, x1 is 1, x2 is 1, r is 1. Then all these updations are happening based on this input. So it is going to find out the parameters satisfying all the rows actually. So that is the concept here. So now what we do here is, so now every transformer will not have only one encoder. How many encoders are there? 6 encoders are there. 6 decoders are there. One encoder itself, that computation, how many computation with the data set. All is, every encoder is a one neural network. Fully forward network. I mean, fast forward network they will call, or fully connected network they will call by any name, no issues actually. And another name for, and what is the algorithm with which this network works? Back propagation algorithm. Error created at the top is coming down, distributed in the iterative updation, we saw it actually. So like that, the encoders are all identical structure. Each one is broken down into sublayers actually. These are the things actually. So every encoder will have a self-attention. This is another neural network. This is another feed-forward neural network. So now, see here, encoder, decoder is also self-attention. What is the input? Who is going to give the input for the encoder? This two, I mean, remember that 256 thing actually. So this gives the input, and this is being sent to first self-attention. Self-attention is to capture what the one score it will provide. This is the score it will provide actually. That is, what is the score? 1 minute, I'll show it to you. Self-attention score. Self-attention score, 1 minute. It is here. It is in this slide. Self-attention score. One minute. This is the score matrix. That is, the self-attention gives you the score. So position 1 values. The word in the position 1, position 2, this like this, which is having the maximum score, that is more related actually. So like that, I'll give another illustration also, don't worry about it. So now, all these things. So see here, encoder self-attention, JE, this given input is x1, x2, and it gives an z1, z2, z3, then feed forward, and it goes like that. So like this self-attention, that is, I'll tell you, this is the word. For example, for self-attention, the animal did not cross the street because it was too tired. What is this? It refers to, whether it refers to street or animal, we know the human being that it refer, because before that animal and street has come. So what we have to do, we have to identify which refers to. So for that only attention. Every word is compared with everything. Now see here, the score for the similarity index with the usual, the will be converted into a vector, animal will be converted in vector, and we will find out the dot product. So for example, if the dot product between animal and it is higher means, so it refers animal. That is the thing. So now self-attention, what is the thing is, we are having in the self-attention, we are having three things actually. Is to create three vectors from each of the encoder input vectors. So for each vector, for example, thinking, mission, embedding, I am converting that into a vector, numerical representation. There are many tools to embed as a vector, and x2 is mission. Then I am raising one Q1, Q2, based on Q1, Q2, one query matrix I am creating. In the same way, for each word I create a K1, K2, WK I represent. For each value I am creating, for each word I am creating V1, W2. Based on that, what is the thing I am going to create, I am going to do this calculation, x1, x2, queries q1, q2. I am going to calculate the dot product between q1.q1, q1, q1.q2, q1.q3, like that. This is the score thing. After that, what I do here is, from the same thing, I am going to find out, softmax calculation. Softmax is what? If there are many values, you take one value and denominator will have 1, 2, 3, 4 softmax is 1 by 1 plus 2 plus 3 plus 4. That is to give a probability representation to know which is higher. That's the only thing actually. So like that, this is the thing. Now I come back to the, so matrix calculation, this is your input vector. This is your query vector. I find out WQ for each word, that query vector, this is the column vector. So like that, we calculate. This is the basic attention, all these things. Now I'll give a small calculation before we wind up. The simple calculation, what I'll share this with you so that you can better understand that actually. Now I'll share this 1 minute. Yeah, untitled. See here, all the things which we have made it here, it is, I have made it. So first thing is, self-attention using query queue. So for each word in the input sequence, why we are doing this thing, to understand the relationship and how the prediction happens, I'll make it out actually. Self-attention is a fundamental component of the transformer architecture. Each word in a sequence is to attend all the other words in the sequence in order to build a context-aware representation. Context awareness means what? How each word is related to other words. That for that we are going to have just simple matrix multiplication. Of course, dimension is very heavy. For dimension, we have the computation source. So basically, what is happening here is just matrix multiplication. For each word in the input sentence, a query vector is computed. The query represents the type of the word is searching for. It encodes the question, which words in the sentence are relevant to me? For example, for each word query is created, so it will search, okay, which are all related. The animal went to the forest and ran away, and it ran away. So animal will compare this with that. So the animal will find out it is, the word IT is more close to me, like that. So to find out which word is close to which word, I am going to find out this query. So it will raise the question, which word in the sentence are relevant to me? Each word produces a key vector. The key represents what is the meaning it offers, that is called key. I am Jagannathan means I am a human being. I can say this is one of my key actually, or I am a faculty, I am a teacher, something like it. If the query means who am I? That is what I will be doing actually. Who are all friends to me in the whole world? I want to find out which words in the sentence are relevant to me. That is for each word in the given input, Q will be calculated, K will be calculated, and Q dot K will be calculated as score of QIAJ dot product actually. The scores are scaled down just to knock. Scaling down means instead of 50,000 size, I am making it 256. So I am calling that as alpha ij, softmax of it actually. The attention weights indicate how much important the word assigns to each other words. Then comes the value. Each word has an associated value vector that contains the actual semantic information. That is, semantic information meanings are related. For example, I went to a bank near the river bank. I went to a bank near the river bank. This bank and that bank are not semantically related. Meaning wise, they are not related. That river bank tells the border of the river. This bank tells the bank where we put money and take it. So to know that semantic connection, what we do here is we calculate something called value. Values are used to construct the final representation. Then context-aware representation, the output of the self-attention for a word is obtained as a weighted sum of the value vectors actually. Okay, now this value vectors, the sum alpha ij will be calculating. Already we have calculated alpha ij here. So that I will substitute output of it actually. Now why this is called self-attention? Because the queries and keys and values are all derived from the same input sequence, allowing every drama happens within that sentence only. So self-attention. So now I am going to interpret with an example. Query, key and values actually. Consider the sentence AA helps education. What are the words? AA helps education. I want to know the score for how much AA is related to some other words. The goal of self-attention is to compute a context-aware representation. Context-aware representation means how much relationship each having. For each word, by allowing it to attend to all the words in the sentence, this is achieved by using the concept of QKV. So the query vector for Q vector for help, I am making it 1, 1, 1 initialization. This query is compared with the key vectors of all words in the Q helps. I am going to compare with that. For K also, what is the thing? Each word for key I am going to find out one vector. So for example, I am making one input. This is the input and this is the projection WK, W. This is the weight matrix of the query. First word, second word, second word, and I am calculating Q is equal to XWQ, K is equal to XWK, V is equal to the all matrix multiplication, attention scores it's making down. Each row, how strongly one word attends to all the word. So first word is not having correlation to the second word. What is the thing? First and second word are having correlation. So now I am scaling and with this 110-231 I am making using the softmax actually. So for example, what is the thing? I am making as a 1-to-1. I am making 1-to-1 like this. I am making multiply. This is root 2 division is just to make the numbers looks very small without losing any meaning. So this is called score matrix. So this matrix tell you that of the 3 words, first word and third word are related to the level of 0.16 like that actually. So final attention output for token helps, I am going to give A into B. A is the given, A is the score matrix and value I am making it, I am multiplying it. So this, what the token helps, this is the score. So token helps, the importance given for the second word is 1.58 and 0.54. So now here, this is the query will do what a word is searching for. Key will do what a word offers. What is my offering? And information carried by the word. This attention is the importance of each word to another. So now coming back to the final prediction, the masking we have done, final prediction. So now a common is that query key value is not the self-attention mechanism. Query key value is going to give you the context-aware score matrix actually. Given sequence of embedding, self-attention computes that is equal to this. This operation produces a context-aware vector for each position, that's all. So output of this is passed through position-wise feed for another feed-forward network I am going to make. So now using feed-forward network, another deep learning architecture actually. Next word prediction is prepared by projecting the hidden representation using this hypothesis. What is this H W naught plus B? This is the vector. I mean H is the input given to that actually. H is the output. So like W naught x1 plus W1 x1 plus W naught x naught plus W1 x1 plus W2 x2. Like that I am making it another network, and based on the thing, finally, what is for every feed forward network, what is the thing? We should have a prediction at the end of the thing. So this prediction, we will have it here actually. So probability of the next word is softmax of log x. Log x is your equation, when H W naught plus B. This is another mathematical equation. This you can understand this as W naught x naught plus W1 x1 plus W2 x2 like that actually. Then like that we make it like a softmax prediction is softmax of Z1, Z2, Z1 is e power Zi by sigma summation of it actually. For log it will be e power Zi. For normal thing 1 by 1 plus something actually. So like that it goes on. Now we scan through that architecture. Final architecture will be like this. This is fully, all these calculations are what I have told here it is, so that you can go through and see the related papers actually. Now, what is this is the full architecture. How many encoders are there from the thing? Encoder is another big, feed forward network. This is another 6 or feed forward. Why it makes this first word with all these words, second word with all this word, third, sir, why not 6, why 16? There is no concept behind 6 or 16. You can have 8 or 9. It depends upon your computing power. They run their experiment trial and error, and they got this actually. And I'll make this paper also. I'll show it to you. This is the paper with which into all these calculations are Vaswani. Attention is all you need. This is the turning point in the transformer architecture. So this is the full transformer model architecture. See here, input embedding means where this words are converted into vector and positional embedding, and we are having self-attention and feed-forward network. This encoder is given to, this is the how many encoders we can, this is one sample actually. Like that we are having how many encoders actually? 6 encoders we have actually. And like this input is given to, this one, and finally this thing. See, don't think that this small circle is just one calculation where it is being done when x is input, x plus 2 is calculated. Everything is a deep learning architecture. And how many parameters are there? 50,000. More than, that's what I am telling. This, here I am telling, this is the thing for you. Here we are calculating 9 parameters, that's all. Just 9. There, in the ChatGPT, if you type 20 words, actually everything will be made into this type and made it out actually. And we use that large language. This transformer architecture has speeded up the computation power. Even this encoder decoder architecture were existing before 2017. But in 2017, this transformer architecture paper came. Then the things got speeded up because everything is being done in parallel. That is the thing. So this is the encoder, decoder, all this calculation which I shown, which notes I have prepared, all this thing. So now to understand the thing, this is the original paper, full of mathematics. everything is a computation here actually. No, and that computation is based on the gradient descent. Gradient descent is the formula which I refer for this. This is the thing based on the gradient descent. This is the formula, the iterative formula. All this iterative formula is an output of gradient descent. Can you? So like that it goes on, and though I don't know whether you have got the feel of it fully, but at least what is happening in the deep learning architecture, you would have thoroughly understood. The same logic you have to carry. Only for that reason, I leave you with this, this small notes prepared for the purpose of it, so that simply you can understand everything. And full calculation is also here in this article. This is the one standard article. Video is also there. Earlier it was like a blog. Sometime back in came in 2018 or 2019. It came before the thing one. The video is also there. Now it has become a chapter in one of the books, hands-on large language model. For large language model, which is the core brain, is the transformer. That is the thing here I am making it. So the transformer, everything is happening. So transformer is what? And if you can use this transformer for translation, if you have this transformer, translation data set with you. You can use this transformer architecture for summarizing it. If you have a summarization, that is, summarization means there should be a table. First column of the table will be one para. Second column will be the summarization. So this data set will be created manually by us. Based on the data set, this architecture is getting trained, gives an output. So if the transformer is used for summarizing the thing, if I give a big 1-2 page essay here, it will do all this calculation and finally come out with the para which is summarizing it actually. And question answer. If I ask one question, it is answering chatbot concept. What is the thing? Data set will be there. What is your name? It will tell my name is. What is in your head? Like that, I will prepare a data set fully. Like I showed you, if I prepare a data set with all the addition concept, without knowing addition, I can train this model to give an output of, you can give 200-digit number addition. It will do it actually, based on this. It is predicting the next word. So prediction matters here. And that is the thing here. And this article is also a full-fledged article where we can go through everything, detailed explanation with all the process. Maybe I could not cover it fully, but all this mathematics involved is here actually. What is this calculation? Sample calculation, because the real calculation, it scales up. Billions of parameters will be there. But what is this? To understand that, here he is making 3x3 matrix and other things actually. So now this is the matrix like that. Okay, is computing the score matrix. And this normalization is just to compress the image. I can't have 4,000 digit number, so I want to compress actually. This dimension square root of k, so that it will come to all these vectors. And all these vectors, it is getting multiplied with this. Finally, it is given to that. The final prediction is happening here. So all this drama happened just with the matrix multiplication, that too with the dot product, that too with cosine similarity. Nothing other than that. Score matrix, dot product. Dot product is nothing but your cosine AB cos theta. That's all. So those things, and also if you have a time, you go through it. It can't be covered in 90 minutes. But still, I think that I have given a glimpse of it and final thing. But of course, whether this is the final thing, but the lags of which word is having the highest probability, it will be the output. And we will be, repeating this procedure. So all this, again, I'm telling all this rectangle or oval shaped thing stands for a very big neural network. That is the thing. So now, can I stop here actually for answering any questions? Only thing I think that I could not cover it, but I have given a feeling of it, and I'll share all this material, that is the small notes prepared for it, and this paper, and this one, this paper, and this illustration, this article. And these things, I leave it for you. that here I have given masking, very simple sentence, it has been explained, and where does the next prediction. So QKV concept is going to give the full projection of it. That's all actually. So now, before I wind up,
Sir. Sir.
Jagannathan sir.
Sir.
Jagannathan sir. So we are unable to hear your voice.
Sir.
Haris sir, I think Jagannathan sir has some technical issue.
I think.
Please go ahead, sir.
Okay, sir. Okay, sir. I think sir is joining in mobile, sir.
Okay, sir. Meanwhile, you ask the students if they have any
Okay.
inquiry.
Okay, sir. Thank you, sir. Thank you, Jagannathan Garu, for your lecture on mathematics of transformers. This is the time for question and answer session. Because of huge participants, any participants who is interested to clarify his or her doubts, please come forward to post it only in the question and answer box. Q&A box you are going to have. You post any queries in that box.
Sir, please call them once again, sir.
Okay. Once again, participants are requested to post their queries in the Q&A box, if any. Post the queries in the Q&A box, if any.
I think sir has some network issue, sir.
Yes, sir. Yes, sir. Okay, students. Meanwhile, I want to share a small information for all of you. So it has been observed that a few students have not yet submitted the feedback. Please note that submission of feedback is mandatory for the issuing of certificate. There is no need to worry about yesterday feedback. Kindly ensure that you submit the feedback at the end of the session from today onwards without fail. And the second important thing is attendance is also required. Therefore, all of you are encouraged to attend as many sessions as possible to gain maximum benefit from this workshop. Okay. So two things are mandatory: filling the feedback sheet and attending the sessions. Okay. Thank you all. I'm waiting for a resource person.
LJ sir.
Sir.
Sir, please make a call to him and take his permission, sir.
Okay, sir. Okay, sir.
So if students have any doubt, we will send it through his mail and he will definitely respond to them.
Sir, Sir is going to join, sir.
Okay, sir.
So, dear students, today also we are going to share a day 2 feedback form after vote of thanks. All of you fill it immediately after the completion of this session. Please wait for 2 minutes. After resource person joins, we will conclude with vote of thanks.
So on behalf of Maths department, we sincerely appreciate your interest and active participation by registering for our international workshop. This workshop is a valuable opportunity to understand the vital role of mathematics in academics, research, and real-world applications. So it has been observed that a few students have not yet submitted the feedback. Please note that submission of feedback is mandatory for the issuing certificates. There is no need to, don't worry about yesterday's feedback. Kindly ensure that you submit the feedback at the end of the session from today onwards without fail. Additionally, attendance is also required. Therefore, we encourage you to attend as many possible sessions to gain maximum benefit from this workshop. So we look forward to your enthusiastic participation.
Hello?
Sir, we are waiting for you, sir.
Yeah. The charger, I didn't notice it got down actually.
Anyway,
okay,
sir, wonderful lecture, sir.
But I don't know whether it has reached the students or not. I'll share the content if there is any.
Definitely, sir. Really introspective and useful information to the students.
So that, but they have to top up with the thing and they have to go through the document, only then they can get the feel of mathematics.
Yes, sir.
Basic, all this drama is based on just a differential calculation gradient, that is partial derivative of a function of several variable and the matrix multiplication, nothing other than that.
Yes, sir.
But with this, we were able to do this wonder called language model with the transformer as the core brain of it. That is the thing actually. And if any questions, if they are not ready with the question, I will share the PPT, my mail ID and this phone numbers are there. They can feel free to contact me.
Sure, sir.
Okay, fine.
Thank you, Jagannathan Garu, for your wonderful lecture on mathematics of transformers. Okay. So thank you one and all for your good response and valuable support. Expecting the same cooperation for the remaining sessions also. Today's session concludes with vote of thanks by Staff Coordinator Sri I. Pothuraju.
Good evening to all. On behalf of the Department of Mathematics and the participants, I would like to express my heartfelt thanks to our today's resource person, Dr. L. Jagannathan Garu, Professor, School of Computer Science and Engineering, Vellore Institute of Technology, Chennai, who gave such a good and informative presentation on mathematics of transformers. Despite of his busy work schedule, he gladly accepted our invitation and gave a valuable talk in today's session. Thank you very much, sir. I would like to thank our beloved head of the department and convener of this international workshop, Dr. Kevin Acharyalu, sir, who guided and supported us to do this program. I would like to thank our principal madam and our management Bapatla Education Society for providing us all the facilities and encouraging us to conduct this program. I would also like to thank Dr. K. Mandeep Garu, HOD Department of AML, Sri N. Kiran Kumar Garu, MCA HOD, and Sri Kodesarao Garu, Faculty of MCA Department, and Sri U. Venugopal Garu, who are sincerely extending their technical support to us in conducting this international workshop. Thank you, one and all.
Dear
Okay,
students,
sir. Thank you.
thank you all. Now I am
Thank you.
going to share the feedback link in this WhatsApp group. Okay, please all of you fill the feedback link immediately. Thank you all.
Thank you.
You can leave the session. Thank you, sir.
Thank
Jayanathan
Sir,
Garu,
thank you
very much.
sir.
Thank you, sir.
Thank you, sir.
Thank you.
Sir, unable to hear your voice, sir.
Yes, sir. I can hear. I can hear.
Sir?
I can hear.
Okay, sir. Thank
I
you.
can hear.
Okay, sir. Okay.
I can hear you.
Thank
I
you,
can
sir.
hear.
Thank you.
Okay, fine.
Thank you very much.
Thank you.
Thank you,
Okay.
sir.
Okay. ఈ సెషన్ క్లోజ్ చేయాలంటే ఎలా